All right, guys, our next section is graphing linear inequalities. So we've already covered what an inequality is. That's when we have those alligator symbols, that less than or equal to, greater than or equal to. And if you remember when we did inequalities, we had solution sets. You had more than one answer because if you have x is greater than 3, well, that means 4, 5, 6, 7, and so on. A whole bunch of numbers represent the answer. So we had solution sets. We had more than one answer that satisfies that inequality. This time we're going to be talking about linear inequalities, which are inequalities that have an x and a y. Inequalities. I'm going to say that compare two variables. So originally we just had an x or whatever variable we used. Now we're going to have an x and a y, and we're going to graph lines with it. So the boundary line is actually going to be a line that we graph that represents the inequality. Oops. A line graphed that represents the inequality. So our boundary line, we actually graph it just like normal, use our y-intercept and our slope, or if it's in standard form, use your x-intercept and your y-intercept, or anything like that. Or if it was given in point slope form, you could use your point and your slope, any way that you remember how to graph. Then we have special ways that we represent that boundary line. So a dash boundary line means the solutions are not included. Okay, so if you remember way back when we first talked about inequalities, if you had 3 is greater than 3, that was not true. So those answers were not included. We did open circles. So now when we do a line and we're graphing a line, we use a dash boundary line, which is literally just dashes, to represent things that are not included. So instead of open circles now, we're doing a dash boundary line, and the symbols that would go with that would be less than or greater than. A solid boundary line means that our solutions are included. So before, you could have 3 is greater than or equal to 3. That is true. And we did closed circles there. Here we have a solid boundary line, which is actually just a line like we've been graphing, a straight line. And that means that those solutions are included. They do make the inequality true. And the symbols we use for that is less than or equal to and greater than or equal to. Okay, the other thing we have for linear inequalities are what we call a half plane. This is a shaded region that represents all possible solutions. So that's kind of like before when we had those number lines and we would make our closed circle or open circle and we would draw an arrow, shade one half of it, another side. Well, now we have a line. So basically we're in 2D now. We have a line, we have an X and a Y. So our half plane is going to represent half of a coordinate plane where all possible solutions are. A test point would be, it's a way to test to see which part to shade. Which region to shade, not shaded. All right, so let's walk through some examples of linear inequalities, and that'll explain each one of those words. All right, so first one, it says list 5 graphs from, or 5 solutions from the graph. So this is the graph of y less than or equal to x plus 3. So it just wants you to find 5 coordinate pairs or ordered pairs that are on these in the half plane. So since this is a solid line, you could pick one that is actually on the solid line. So one answer could be 0, 3. Then you can do anywhere else in the shaded region, because the shaded region represents any possible answer. 2, 1, 3, 2. Okay. And you can also always check this. If I plug in 0 for x and 3 for y, and then simplify it, I have 3 less than or equal to 3. That is true. And you can do the same thing for 1. 1 is less than or equal to 4. That is also true. And keep going. If you plugged in anything that was on the outside of the shaded region, it would not be a solution. So shaded regions, or the half plane, is where you'll find solutions to the linear inequality. On this one, I have the graph of y is greater than x plus 3. So this one, my boundary line is dashed, so it is not included. So I cannot pick any ordered pairs along my dashed line, but you can pick anything on the inside. Doesn't matter as long as you pick 5 that are in that shaded region, because that is where all of my solutions are. So -4, 3. -3, 3, -2, 3. Okay, just to recap, possible solutions are in your shaded region, your half plane. If the boundary line is solid, that is also a possible solution. If it is dashed, it is not included. Do not pick any solution along that. All right, example 2 is 1, 2, a solution to the inequality. So you can plug in 2 for y and 1 for x and simplify it and see if it is actually true. So 4 times 1 is 4, minus 1 is 3. So it's 2 less or greater than or equal to 3. That is not true. Okay, then you do the same thing here. You plug in 7 for y and -4 for x, and you simplify. That gives me a positive 12 plus 2. My alligator is eating the bigger number, so the answer is yes on that one. So if you want to know if something is a solution, just plug it in, see if it's true or false. All right, now if we want to actually graph them, my first step to graph them would be same thing anytime I'm graphing. Find y-intercept and use my slope. You always start with your y-intercept and then use your rise over run to simplify. Just a recap on slope. Remember, my top is up and down, so if it's positive, I go up. If it's negative, I go down. And then if my bottom number is positive, I go right. If my bottom number is negative, I go left. And then y-intercept, remember that means start on your y-axis, which is the one that goes up and down. All right, step 2 would be to decide whether it's a solid or dashed. Step 3 would be use a test point. And step 4 would be to shade the half plane. All right, so we're going to go ahead and do these steps to graph. All right, so on this one, I have y less than or equal to 4x minus 7. So my m is 4 and my y-intercept is negative 7. So I'm going to start at negative 7 on my y-axis. 1, 2, 3, 7. Okay, and my m here is 4. I'm going to make it a fraction, so I'm going to put it over a 1. 4 is positive, so I'll go up, and 1 is positive, so I'll go right. 1, 2, 3, 4. Okay, on these you do want to make sure you're going to go through the entire graph. So make sure that you make multiple dots because it's a half plane, so you have to literally cut your graph in half, so you have to extend your line through the entire thing. All right, then you got to decide whether it is solid or dash. I have that equal to portion, so this is a solid line. So I'm just going to connect my dots like normal on this one, since I have that equal to. And again, I do want to cut my graph in half, so I want to make sure that I extend it through the entire thing. All right, then we use a test point. For test points, the easiest test point to use is 0, 0. So 0, 0 right here. The only time you can't use 0, 0 is if your graph actually goes through 0, 0, meaning you don't have a y-intercept at all. So unless you go through 0, 0, I would use it. It makes your life a lot easier. So you plug in 0 here for y and 0 in for x. 0 less than or equal to negative 7. So if that's true, you would shade the area with the test point. If it's false, you would shade the area without the test point. So this one is false. 0 is not less than or equal to negative 7. So I'm going to shade the other half of my graph that didn't have that test point in it. And you don't have to shade anything that great, but just make sure you shade it. Okay, then the last part is to represent two solutions. So you find any points in that shaded region that you've created. So 5, 0 and 6, 0 would be in there. And then two non-solutions. Well, I already know 0, 0 doesn't work. And then I could do 0, 3. That also is not in my shaded region. Solutions in the shaded region, non-solutions on the outside. Okay, and that's how you do it. You graph it like normal, decide if it's solid or dash, use a test point, and then shade. All right, go ahead and do this one on your own, and I will show the answer here in a second. All right, for this one, you should have started at 6 and went down 3 over 2. And you should have used a dash line because I have that greater than piece. I don't have an equal to, so I have a dash line. Then I plugged in 0, 0, and I got 0 greater than 6. That is not true. So I shaded my half that didn't include 0, 0. And then I listed off two solutions that were in my shaded and non-solutions that were not in my shaded. I did pick 0, 6 as my non-solution because if you plug that in, it doesn't work. You get 6 greater than 6, which is not true. Okay, and that is how you do linear inequalities.